So looking at your packet, you're supposed to do 31 through 43. How many of you at least got number 31 done? Okay, so number 31, what'd you get for T?
2.
What'd you get for T?
0.5.
0.5, yeah, use that backwards. B? 36, and C? 72. Did you figure out what you did? Yeah, for the 2. It should be 0.5 or 1/2, yeah. Because you have T and 1, right? Then down here you've got B is 36 and C is 72. So 1 over T or T over 1. 1 is horizontal, the 72 is horizontal. T is vertical, the 36 is vertical. If you cross multiply and divide, you get 0.5 or 1/2. Either switched them around or something. Okay, 32. What'd you get for A?
85.
I got 40. B? 50, and C. Okay, let's take a look. So if this is 42, 8, 10, 12, and 98. You can figure out that this here, by taking 42 minus 10 and 12, you can figure out that's 20. Right? Now you're given a 0.4 to 1 aspect ratio here. 0.4 over 1. The 20 is vertical, so that's going to go with the 0.4. This dimension right here then, which is B, we're going bottom. If you cross multiply and divide, you're going to get 50. Once you have that's 50, then it's just 98 minus 8 minus 50 gives you 40 for here. I maybe should warn you that these pictures are definitely not drawn to scale.
Oh, yeah.
It's done intentionally to deceive you a bit, make you trust your numbers. Number 33. What'd you get for A? 24, good. B? 48, and C? 80, good deal. Any questions on those? Okay, I want to do 34 and 35. I want to give you guys an extra day to think about 36. 34. This is 15 threads per inch. That means one thread is 1/15 of an inch, right? If the bolt is 2 1/4 inches long, I can do 2 1/4 divided by 1/15, or I could just do 2 1/4 times 15 because there's 15 threads per inch. And you are correct. That gives me 33.75 threads. How deep are the threads then? Well, if this is a 2 to 1 aspect ratio like this, this is a 1/15 inch wide, that means the run here is how big? 1/30 of an inch, half of a 15th. Because the 15th is the slope up and the slope back down. So if that's the 30th of an inch, how do I find this height here? That's a 1 to 2. The 1/30th goes with the 1. Cross multiply and divide, it's 1/15 of an inch. So the threads are 1/15 of an inch wide and 1/15 of an inch deep. Typical threading, by the way, is a 2 to 1. Questions? Okay, 36, I want to give you guys some more time to try. Make sure you have that one done for next time. We're going to talk a little bit more about tapers and things like that today. I'm going to see what you remember here. Pretend those lines are straight. Yes, you do. See if you can remember the formula for a taper. Calculate the taper of that piece. I'll tell people to keep calling me more in class. How's that? So what'd you get here? 1.125. Okay, so it's 3 3/4 minus 2 1/4, which of course is 1 1/2, right? Over 16 divided by 12, which is 1 1/3, correct? Which is what, 9/8? Or 1.125 inches per foot. Why is taper listed always as inches per foot? Because I told you so. You learn well. I like that. Because it is always inches per foot. Inches of diameter changed per foot of run. Okay, well, let's do another one. Let's say that we have a 1/8 scale. How big do you draw a 4 1/2 inch part? Again, try that in your notes. Just a 1 to 8. Not a 1/8 to 1 foot, just a 1 to 8. So 1 to 8, where does the 4.5 go? It goes on bottom. Because that's the 8 is the actual, right? So now 1 times 4.5 divided by 8. 0.525.
4.5 divided by 8, I got
2625, something like that. 0.5625. Okay. So 0.5625, otherwise known as 9/16.
That's a pattern I figured out.
The 16th. Good deal. You get your gold star for the day. Let's say your feed rate is 3,007 per revolution. How far in 1 minute at 1200 RPMs? In other words, what I'm asking here, if you have this is actually a rate, not a ratio, of 3,007 per 1 revolution. 1 minute at 1200 RPMs is asking how far it's going to go in 1200 revolutions. Because 1200 RPMs is 1200 revolutions per minute. So how would we solve this? Well, we would cross multiply and divide to get 3.6 inches in a minute. Make sense? So in your notes, try to figure that one out. At 0.4 or 4 thousandths of a 4 thousandths of an inch per revolution. How far in 1 minute at 800 RPMs? So what'd you get? 3.2 inches? Perfect. Well, let's turn that around a bit. At 0.002 inches per revolution, find RPM if you move 2.8 inches in a minute. See if we make that work backwards. So you've got 0.002 inches per 1 revolution. 2.8 inches. You cross multiply and divide. What do you get? 1400 RPM. Very good. 1400 revolutions, and since it's 1 minute, it's 1400 revolutions per minute. Okay. So we've got those two gears. This gear here is turning at 350 RPM. Remember how to find out how fast this gear is turning? See if you can remember. Just so you're counting right, how many teeth does this one have? And this one, 10. Give it a shot, see what you come up with. What'd you come up with? 250 is a little small. 490 sounds better. Remember, this is an inverse proportion. The number of teeth gets smaller, the RPM has to get larger. So we're not doing ratios, we're doing products. So it's the number of teeth times the speed, size times speed. So 14 times 350 equals 10 times x. So now we're going to cross multiply and divide. Or actually not going to cross multiply, we're going to multiply and divide. 14 times 350, which is 245 or something like that. 4,900? That doesn't seem right. Is this 4,900? Really? Holy crap. 4,900, then divide by 10 is 490. So it is 490 RPM. Just like if we have a 5-inch pulley here, a 12-inch pulley here, and this pulley is turning at 600 RPM. Find how fast that pulley is turning. So how do we set it up?
600 times 5.
Yep, I usually do 5 times 600, but same thing. Equals 12 times x. So this is 1200, right? Divided by 12 is 100. Is that? No, it's not 1200. What is it? 3000. Thank you. I'm off today. Really bad. Divided by 12 is what, 250? 250 RPM. I'm going to stop doing calculations in my head for the day because apparently that's not working for me today. Let's say I'm going to draw this a little bit better here. We have a 1-to-1 slope here. Pretend that's a ball. It sits in here. And I want to know how tall it is to the top of that ball from the bottom of the thing. If this ball has a diameter of 1 inch. Well, if that ball has a diameter of 1 inch, we know it has a radius of how much? 0.5 inches. We also know that that radius forms what angle with this tangent line out here? Right angle, always, both directions. So we know this is 0.5, we know this is 0.5. Well, how can we find anything else of meaning here? Well, if I knew how far it was across here, I would know how far it was here because it's a 1-to-1 slope, right? Well, I know if I extend this down here that this portion is how big? 0.5 inches, correct? This has got to be a right angle. So if I could find this dimension, I could make it work, couldn't I? Well, I'm going to focus on this line right here and what I can do with it. That line is 0.5 inches. I really want to know, I'm going to have to know that length and that length. I'm going to call this X and Y for now. Obviously because X is horizontal, Y is vertical. What do I know about those? I know there's a 1-to-1 aspect ratio on this line here. If this forms a right angle, its aspect ratio must also be 1-to-1. If I have a line here, let's say this is a 2-to-1 aspect ratio. If I have a line perpendicular, all it does is flips the aspect ratio. This is now going to be a 1-to-2, right? That makes sense? Opposite reciprocal slope. Well, this is 1-to-1. You just flip them, it's still 1-to-1. So I know that this is a 1-to-1 aspect ratio. If I just knew this hypotenuse, I'd have similar triangles, wouldn't I? Can I find that hypotenuse? I'll call that h squared. 1 squared plus 1 squared equals h squared, right? It's a right triangle. A squared plus b squared equals c squared. 1 squared is 1 plus 1 squared is 1 equals 2 equals h squared. So I square root 2, I get 1.414. Is that correct? That's why I'm asking you if it's correct. 1.414. So 1.414 is close enough. So now that I have that, I can find x and y. Well, first of all, this is 1-to-1. X and y are equal, aren't they? I could find them separate, but I don't have to. Once I know one, I know the other. So 1.414 relates to 0.5 in the same way that 1 relates to x. And I'll cross multiply and divide. 1 times 0.5 is 0.5 divided by 1.414 is... So 0.354 we're going to call it. So now I know this little piece here and this little piece here are both 0.354. So what does that tell me about this distance from here over to here? 0.354 plus 0.5, because this is 0.5, this is 0.354, that adds up to 0.854 inches. Make sense? So that means from here down is also 0.854 inches. What's the distance from here to here? Well, we said this dimension here is also 0.354, didn't we? So that's 0.354, and what about from here up to the top of the ball? 0.5. My radius is 0.5. So I add that all up, and I get 1.708. Is that correct? Inches. So my height from down here to the top of the ball is 1.708 inches. Does that look doable? That's a little trick you can do with these aspect ratios, and that's what I wanted to show you, is this piece here. If you have the aspect ratio, you can treat it as a right triangle, find its hypotenuse, and use it as a similar triangle to other figures that have that same sloped surface. I pointed that out because number 43 in your homework on your packet requires you to do that trick. Also, in that other packet you had, the machine tool packet, 36 will require you to do it. 36, yes, you could use it on 36. Also, in the machining packet, the other packet, not the one that's typed up, the one that we were working on last week, in that packet on page 234, I have you do 1 through 7, and on page 236, I'll have you do 8 through 10. Just some more problems with ratio and proportion. And keep working on that other packet. Make sure you are done up through 43 for tomorrow. There will be a quiz tomorrow.